Okay, so what we're looking at here is we're looking at finding the volume of a cuboid, and in order to do that, what we've got to do is first think about what volume is. So remember that volume, when we're trying to find the volume of a shape, we're looking for how much space is contained within it. Often to do that, we split it into littler cubes when we first start looking at the volume of a cuboid. And so here, at this example, you can see that I've drawn a cuboid and tried to mark on where the little cubes go. There are 4 along the bottom, so we've got 1, 2, 3, 4, and then there's another row of 4 above it, and another row of 4 above that. Okay, so we can see that, hopefully, that I've drawn them very badly, that we go 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 cubes there on the front of that shape. Okay, now we can see them kind of around the side. So that there is just the edge of cube 4, the edge of cube 8, the edge of cube 12, and the same thing along the top. Okay, so there are also, that's the top of 9, top of 10, top of 11, and the top of 12. So there are 12 little cubes that make up the front of that shape, and there are 12 little cubes that make up the back bit. Okay, so hopefully from the side we can see that there are 2 sets of cubes that are appearing there. Okay, so we've got 12 at the front, 12 at the back, and that gives us 24 altogether. Okay, so how can we find an easier way? Okay, we don't want to have to sit and draw them all out all the time. How can we use this to help us a little bit? Well, there's 4 along the front, but there are 2 back the way, and there are 3 stacked up and down the way. Okay, and what we should find is that actually when we multiply all these numbers together, 4 times 2 times 3, we end up getting 24, just like we did a minute ago when we had to sit and count all of the cubes. Okay, 4 times 2 is 8, times 3 is 24. And so, you're out of the keyboard. So what we're actually looking to do is we're going to make it a little bit more general here. So when we're dealing with a cuboid, okay, we like to refer to it with a length, a breadth, and a height. So we're going to mark that on the cuboid underneath with our numbers that we've got there. So we've got 4, we've got 2, we've got 3, they match up to the shape just above. So we did 4 times 2 times 3, and it gives us 24. Generally speaking though, okay, we're not always going to have those numbers, we don't know what's going to be there, but there is going to be the length, the breadth, and the height. Okay, so we're going to mark that on. Length, breadth, and height. And so the volume of a cuboid is found by doing length multiplied by breadth multiplied by height. And I'm going to put that in a little box. Okay, so let's try and apply that then. Let's try and find the volume of some of these cuboids further down. So let's start with the green one. Let's have a look at that. So volume is equal to length times breadth times height. So matching it up to a formula. Okay, matching the letters up to the shape that we've just got. How is it going to work? Well, my volume then is 4 multiplied by 3 multiplied by 4. So I've got a length of 4, a breadth of 3, and a height of 4. Okay, so hopefully we can match those numbers up happily enough. 4 times 3 is 12, times 4 is 48. Now the difference with this one is that here we've got some units. So the lengths of the lines are in centimetres, so we're going to be dealing with 48 centimetres, but now we're dealing with volume. Okay, so we need to signify that we're looking for something in 3 dimensions. So we need to put our little 3 there, we need to talk about cubic centimetres. Okay, second one. Volume equals length times breadth times height. It's still a cuboid, and it's the same formula. The problem that we've got this time though is that some of our numbers are in different units. So I've got my length, I've got my breadth, I've got my height, but I can't just put the numbers straight in because my length is 2 meters, but my breadth is 25 centimeters. So I'm going to need to change one of them or two of them so that they all match. The formula is only going to work if all our things are in the same units. So they all need to be either meters or they need to be centimeters. Okay, so I'm going to change my 2 meters into centimeters because that's one less thing then I need to change. So 2 meters is the same as 200 centimeters. Now they're all in centimeters, so I can put them into my formula. So I've got 200 multiplied by 50 multiplied by 25. Okay, so when we're multiplying our numbers, it doesn't actually matter what order we do them in. Okay, so we can swap them around if we need to, we can make them the same, or if you've highlighted your number and you've forgotten it's there, you can write it at the end, just like I did there. So crunch your numbers and you should end up getting 250,000. Okay, the units that we chose to deal with were centimeters again, so we've got centimeters with a little 3, so we've got cubic centimeters are the units we've got there. We need to remember and include our units in our answer. Third example, we've got our length, our breadth, our height. So volume equals length times breadth times height. Underneath, I'm going to substitute in my numbers, 20 multiplied by 20 multiplied by 20. And what we find is that they're all the same. And so we've got a cube. Okay, remembering that a cube is just a special type of cuboid, in the same way that a square is just a special type of rectangle. Okay, so it's just a fancy one. It still works the same way, only all my numbers here are exactly the same. And when we crunch those numbers, we do 20 multiplied by 20, we get 400 times 20 again, gets us 8,000. The units I've got are centimeters, and it's still volume, so it's still cubic centimeters. Centimeters with a little 3 I'm interested in.